Hi, welcome to my channel. So today we have a question from solution chapter which is asking NEET 2021. Let us quickly go through this question and let us see how do we solve this question or how do we approach this question to solve effectively. Okay. All right. So let me take you through the question. So the question says we have three solutions. The following solutions are prepared by dissolving 10 grams of glucose in water and 10 grams of urea in 250 ml of water and 10 grams of sucrose in 250 ml of water. Now they're asking us to compare the osmotic pressure. Fine, fine. So let us take three beakers. Okay, we are taking three beakers, and in the first beaker, what we're taking, we're taking glucose along with water, and in the second beaker, we are taking urea along with water, and in the third beaker, we are taking sucrose along with water. That means we have three different solutions in which solvent is same, which is our water. Only the solute is different. In first it is glucose, in the second it is urea, and third it is sucrose. Okay. Now they're asking us to compare the osmotic pressure. How do we do this? We know the formula for osmotic pressure. The formula for osmotic pressure is equals to ICRT. What is it? ICRT. So what is I here? I is Van Hoff factor. I is Van Hoff factor and C is concentration, which is generally molarity, and R is universal gas constant. R is universal gas constant, and T is temperature. And T is temperature. And if you look here, in all these questions, we are using the same solvent and the same amount of solvent. In this question, we are in all the three solutions. The solvent is same and the amount of solvent taken is also same. Then what is different? Only the solute is different, isn't it? Only the solute is different. In the first solution, it is glucose, which is our solute, and second urea, and third sucrose. Fine. All right. Now, one more important thing in this question is we are given glucose, urea, sucrose, and all these three are non-electrolytes. Non-electrolytes. So, what are non-electrolytes? So, non-electrolytes are those which cannot undergo dissociation. Which cannot undergo dissociation. That means if they don't undergo dissociation, what is their I value? I value is always 1 for all these electrolytes, for all these non-electrolytes. Okay, I value is always 1 for non-electrolytes. So since glucose, urea, and sucrose, all of them are non-electrolytes, I value is always 1. So in the formula, we need not compare I. We need not compare I for different solutes. Next, R is a constant and it's same for all the solutes, all the solutions. Temperature is also same. That means whatever you're supposed to compare, we just need to compare C values, which is a concentration terms. That means osmotic pressure is proportional to C. Fine. And what is C? C is nothing but molarity. C is nothing but molarity, whose formula is N by V. Whose formula is N by V. That means number of moles of solute dissolved in 1 liter of solution. If volume is taken in milliliters, if volume of solvent is taken in volume of solution, I'm sorry, if V represents volume of solution and volume of solution is taken in ml, then the formula of molarity is N by V upon 1000, isn't it? Now, if you look here, in the question, we are adding 250 ml of water, and the same amount of water is added in all these three solutions. That means this is always same for all these three solutions. V remains same. Then what is different? Only the number of moles of solute is different. And how do you find number of moles of solute? What is the formula to find number of moles of solute? It is given weight of solute, given weight of solute upon molecular weight of solute, given weight of solute upon molecular weight of solute. Now, if you look at the question, weight of solute taken or weight of solute is also same in all these three cases. That is, for glucose, we have taken 10 grams of glucose, 10 grams of urea, and 10 grams of sucrose. That means given weight is also same. Then what is making difference? It is molecular weight which is making difference. It is molecular weight which is making difference. That means, so finally what we have? We have pi, which is osmotic pressure, is equals to ICRT, and in the place of C we have taken N by V into 1000 RT. Now, we have discussed that I is same for all, R is same, T is same, and V is also same. And in number of moles, given weight is also same. Then what is different? Only weight of the solvent is different. So finally, what did we end up with? Osmotic pressure is just inversely proportional to molecular weight of solute. That means the solute which is having higher molecular weight is having least osmotic pressure. The solute which is having highest molecular weight is having the least osmotic pressure. Okay, because they have indirect relationship. All right. So we are given glucose whose formula is C6H12O6, and we are given urea whose formula is CH4N2O, which can also be written as CH2, CH3NH2 CH2. Okay, fine. CH2. Then we have sucrose whose formula is C12H22O11. Okay. So let us quickly find the molecular weights of all these solutes. So we have glucose whose osmotic pressure is P1. Then we have urea whose osmotic pressure is P2, and we have sucrose whose osmotic pressure is P3. Glucose P1, urea NH2CO NH2 is P2, and sucrose which is P3. Now, so glucose formula is C6H12O6, urea NH2CO NH2, which they have mentioned as CH4N2, but which is also written as NH2CO NH2. Then we have sucrose, whose formula is C12H22O11. Molecular weight of glucose is 180 grams, and molecular weight of urea is 60 grams, and molecular weight of sucrose is 342 grams. Molecular weight of urea is sucrose is 342 grams. So what is the order of molecular weights? Order of molecular weights is highest is for sucrose. Then we have glucose, and at last we have urea. So this is the order of molecular weights. And how is molecular weight related to osmotic pressure? Inversely. So if this is the molecular weight of this is the order of molecular weight, then the order of osmotic pressure will be reversed, isn't it? So the order of osmotic pressures is as follows. So here, in molecular weights, sucrose is having the highest. So and urea is least. And if you're comparing osmotic pressures, urea should be given highest. And what is the pressure of urea? P2. So first it is P2. Glucose is in between. So it should be in between with respect to osmotic pressure as well. And urea is least here, but here it is having the highest. And sucrose is highest in the case of molecular weights. So it should be least here. Sucrose osmotic pressure is given by P3. So what is the answer? The answer is P2 greater than P1, P1 is greater than P3. So let's mark the correct answer. First P2, and then P1, then P3. So P2, P1, P3, P2, P1, P3, and the same is given here. Alright, so what is the correct option? Correct option is answer 2. Alright, so thanks so much. Thank you for listening to me, and I hope I hope you find this video helpful, and I hope you follow this page. Thank you so much.